Hello student, in this module we are going to illustrate the application of R on diagnostic test for Cox proportional hazard modeling. In Cox proportional hazard modeling we have seen that the basic assumption should be the proportionality hazard. In your sample data the proportionality hazard assumption followed or not, that should be tested, and how to test that will check in this module. When modeling a Cox proportional hazard model, a key assumptions, again I will say proportional hazard, there are a number of basic concepts for testing proportionality, but the implementation of these concepts differ across different statistical packages. The goal of this module is to illustrate how to test proportional assumptions using an example data. As we have seen that Kaplan-Meier curves work best for time fixed covariate with few labels. When we graph the survival function versus survival time, if the predictors satisfy the proportional hazard assumption, then the shapes of the curve should be basically be the same, otherwise not, and the separation between the curves should remain proportional across analysis time. Similarly, the graphs of log of minus log survival versus log of survival curves should follow the parallelity, that it should be the parallel graphs if the predictors is proportional. The method does not work well for continuous predictor as well or categorical predictors that have many labels because the graphs becomes cluttered. Furthermore, the curves are sparse when there are few time points, and it may not be difficult to gauge how close to parallel is close enough. So, testing the proportionality assumptions is very important. In this module, we will illustrate first the plotting the survival curves, thereafter we will check the proportionality assumptions, and after that we will apply the Cox proportional hazard model in a simple data set and make the statistical inference on diagnostic test procedure as well as statistical inference on drug treatment comparison. End of this module, we will see the plot estimated survival curves using R, test the proportionality hazard assumption for a Cox regression model fitting using R, and plot stratified survival curves using R. Let us start. Here is the data, survival data on ovarian cancer study published by Edmondson in 1979, where the observations are a few time, that is survival or censoring time, a few stat, that is censoring status, age in years is considered here, residual.ds is considered, residual disease present or not, Rx, that is treatment group, is considered here, and ECOG.ps is considered, that ECG performance of the status. It is requested to check the medical literature on this details about this ECOG and treatment. Now you will pass this our learning objective through the drug treatment effect comparison. Time is considered in duration in days, like 59 days, 115 days, 156 days for all the individuals observed in this data. Now the second variable is status is given as 1 and 0. If the patient's censored is taken as 1, if it not censored, that's been died, it is considered as 0. Again Rx treatment is given as 1 and 2. So whatever Cox proportional hazard model assumptions result will come, it will be for treatment group 2 in comparison to treatment 1, where treatment 1 is considered as a reference group. Now the all individuals corresponding age during the study initiation is considered here as 72 years, 74 years, like all here first individuals from to last individuals, like here the age is 58.30 years. So now the data set is looks like that. Now we can call other variable like residual dot disease, or again coded as 2 and 1, and ECOG dot PS also coded as 1 and 2. Now all these variable we are calling through data dot frame, and time, status, RX, age, residual dot days, and ECOG dot PS called and assigned to a function by a data dot frame, and this and database called as ovarian is called. Now we are going to load the library. Library survival will be called. Now we will go to next slide. That is our learning objective. Test the pH assumptions of a Cox proportional regression. Thus proportionality hazard is followed or not. Here we are going to use the Cox PH functions to initially to get the model, and the Cox PH, after that parenthesis the capital SURV function will be useful to get the to model the Cox PH values here, and the covariates here is considered, one is age, another one is ECOG dot PS for the data ovarian. Now this whole fit where we are putting into another measure that is called temp, and calling this we are putting another functions that is Cox dot jph, and the Cox dot jph of fit is putting into the temp, and we are calling the temp to, and also calling the plotting the temp value to get. Now see what's happened here, and if we want to put the title of this plot, we will put main equals to into inverted comma ovarian studies. So in case of other reproducible research, however, as your study will be, you can put your study name as main equals to inverted comma all the study title. This is the R output, that is will give the rho value and chi-square value. It gives that how the models are suitable to be considered here or not. Model acceptability can be observed by this Cox jph dot fit and Cox PH with Cox PH function. It is to be noted that the Cox proportional hazard regression model has achieved widespread use in the analysis of time to event data with censoring and covariates. The covariates may change their values over time, but it is to be noted that time independent covariates which offer additional opportunity but must be used with caution. The interrelationship between the outcome and variable over time can lead to bias unless the relationships are well understood. The form of a time dependent covariate is much more complex than its Cox model with fixed covariate. It involves construction a function of time. Further, the model does not have sometimes offer the property of fixed covariates model. It cannot usually be used to predict the survival time curve over time. The estimated probability of an event over time is not related to the hazard function in usual fashion. So what variable we are considering that need to be taken in case here we are considering the age. So here we have assumed that age is not changes for the all individual. Since our duration of study is very narrowed down only for few days, maybe 130 to 200 days, but if the study duration is prolonged, maybe for 3 to 4 years or 5 years, then age factor can be considered as a time varying covector. So in that case, special caution is required to take. Now the plotting for these regressions coefficients of age is given here. It shows that it is quite good to accept that coefficients of age. So age as a covariate is not breaking the pH assumption. It's mostly followed the same pattern over the period from study initiation to study end up period, that is from 100 days to 600 days. So mostly this age is not coefficient of age is not breaking the Cox proportional hazard assumptions. Another variable we are considering here is the ECOG dot PS that also we have plotted and found that it also not changes over the durations. Mostly the same pattern has been observed. Most pattern is observed. So this case we can consider that that model is sustainably good. One thing is to be noted that another problem for making this Cox proportional assumption is the presence of ties. There are three possible choices for handling tied event times before applying this Cox proportional hazard. The Breslau approximation is the easiest to program and hence become the first option coded for almost all computer routines. It then ended up as a default option when other options were added in order to maintain the backwards compatibility. The option that is called Efron option is much more accurate if there are a large number of ties, and it is default option here in Cox proportional hazard function. In practice, the number of ties is usually small, in which case all methods are statistically indistinguishable. Using the exact partial likelihood that we have seen the module on Cox proportional hazard fitting with inference on 1, that we have seen that approach the Cox proportional hazard likelihood is equivalent to that of the matched logistic regression. If it can be performed through matched logistic with the function called C-logit through the Coxs PH code to do the fit. It is technically appropriate when the time scale is discrete and has only a few unique values, and some packages refer to these as a discrete option as well. There is also an exact marginal likelihood due to parentheses which is not implemented in these Coxs PH model functions. The calculation of the exact partial likelihood is numerically intense. Say for instance 50 of 180 subjects at risk has an event of on day 7, then the code need to compute sum over all 180 choose to 15 greater than 10 to the power 43 different possible subset of size 15. There is a efficient recursive algorithm for these tasks, but even with these the computation can insufficiently long with start and stop data. That is, here we are using the status code is much worse since recursions need to start a new for each unique startup time. Now we are going for stratified survival analysis. Here we are using the library called RMS. It is useful to go for stratified analysis. Here the subset function we have used to get the ECOG score from the data. Those are having ECOG score only 1, they have considered from the ovarian study, and the new database is created as ovarian 1. Now we have run the Cox proportional hazard function. Now we have run the Cox proportional hazard function on the data set, that is selected data set from the ovarian study, that is ovarian 1, and the function is URV of FU time and FU stat is considered with treatment, that is Rx here. Now we are going for output. Our output, this output will show that in comparison to Rx1 that is considered as reference group, Rx2 having coefficient with minus 1.61, that is Rx2 having lesser hazard in comparison to Rx1, and since exponential of coefficient coming 0.2, so it is quite lesser than value of null hypothesis, that is 1. So, it can be stated that Rx2 is performing better in comparison to Rx1. So, those patients treated with Rx2 having better survival in comparison to treated with Rx1 people. Now, the corresponding of this exponential of coefficient, the standard error of coefficient also gets, it gives him 1.12 with Z test value minus 1.43 and p value 1.15. It says that, however, these hazard ratio on survival analysis of Rx1 and Rx2 is not significantly differ, but it also states that the treatment groups treated with the Rx2 having better survival in comparison to patient treated with group 1. Here the likelihood ratio is coming with 2.63 with 1 degree of freedom. Again, this likelihood is saying about the fitting about the model. So, it says that quite good, 0.105 is coming, where we are having out of 14 patients 5 events occurred. Now, again we are using the library RMS to plot the survival curves. To get the subset of the data from the ovarian study, we use that ECOG.PS equals to 1 and use the function called subset. This function subset will generate only a new data set, those are having ECOG.PS equals to 1. Now, again we will go for Coxs PH functions. That Coxs PH functions will, again within parenthesis, if we put the sub functions and F2 and time status we will put, and the Rx, that is treatment, is given here, where we are assigning data equals to ovarian 2. Now, this function will give the stratified analysis. Now, we are going for next library, that is called library KM.CI. It is useful to get the confidence interval value of Kaplan-Meier estimates. Now, there are so many methods are there to apply with Kaplan KM.CI. Here the KM.CI, if we put that S1 with method log EP, we will get certain confidence interval. It is requested to check in library KM.CI the various type of options for confidence interval. It is basically 3 types of confidence interval produced by this library. One is this log confidence interval, and that you are showing here as interval which is based on the log of the hazard. The other competitive confidence concept was introduced by Rotman, and it is using the assumption that the survival estimator follows a binomial distributions. Another good confidence concept was invented by Thomas and Grunken-Meyer in 1975, that also taken in this library, and is derived by minimizing that confidence interval concept is derived by minimizing the likelihood functions under certain constraints. The confidence interval using by Pareto variance cannot be used since its yields confidence limits outside the admissible range, that is 0 to 1, as well as the linear and log linear function is concerned. The function can produce simulation confidence band too. The functions given by Hall-Willner band and the equal precision band by Nair 1984 paper is also comes with the log transform counterpart of that functions. From all simulation confidence interval, only the log transform equal precision, that is log EP band, can be used here. So, there are options here, that is meant to say that there are so many options are there, but recommended methods can be considered as log EP. It is having some limitations also. It is requested to check the book of Klein and Moserberger about the limitation of log EP methods. Here we are plotting that curve with KMCI, and the curves is like this, where the y axis giving the survival probability and x axis giving the time, and with different censoring observations marked with different color. So, here since we are having two type of treatment groups, that shows by blue and brown color, and also the censoring observations given here, and the by the cross marks, and its interpretation wise may be but complicated in terms of figure as compared to earlier graphs, but when we are having problem like to defining these Pareto variance and these log estimator. So, this kind of KM confidence interval function can be used for this for as a in addition to the diagnostic procedure of Coxs proportional hazard modeling. In this module, we have seen the diagnostic test procedure to check the proportionality assumptions of Coxs proportional hazard modeling using R. We had plotted the estimated survival curves using R. Thereafter, we had tested the proportionality assumptions on Cox regression model, and we have seen how to check the stratified survival analysis and the survival analysis result we plotted. So, we have learned survival analysis, plot, Cox proportional diagnostics procedure, and the estimation of survival curves using R.